Oh, thanks everyone for coming today. I'll just let everyone know that we are recording this session as there's a number of people who emailed the Engineering Society and said, I cannot make it. Can you record it so I can watch it later? Yep, so we're going to record it. I'd like to thank you all for coming once again. It's been a really great turnout with everyone through COVID lockdowns at the moment. It's great to see you all here. So that you know that the recording will be posted on the Engineering Society Facebook, and we have a number of upcoming events for the rest of the year. Hopefully social events if we get out of lockdown, and some more industry lunches that we have planned for later in the semester. All the information on there will be posted on the Engineering Society Facebook. I'll hand over to Rick now, who's from RDA Hunter, who's helping us run this session.
Thanks, Matthew. G'day, everyone. My name's Rick Evans with Regional Development Australia Hunter. I'd like to thank Matthew Hackett and the Engineering Society for the invitation and the opportunity to help out, and more specifically to provide an industry connection into Lockheed Martin Australia. Just before we move on behalf of RDA Hunter, the University of Newcastle and Lockheed Martin Australia, we'd like to acknowledge and respect the Pambalong clan of the Awabakal people, traditional custodians of the land on which this campus of the University of Newcastle, specifically the School of Engineering, is situated. We've got some really special guests on the line. We've got Sean Owen, Adam Nemiznik and Liam McCowan, and also from Lockheed Martin Australia is Sam Wong. I think I've got everyone from Lockheed Martin on the line, but yeah, I'd like to echo Matthew's thoughts. 56 participants is a terrific roll up. We were hoping to shout you all a lunch at the University of Newcastle in Callaghan, but we'll do that another time. So for a little bit of context and as to why RDA Hunter is involved, some of you, I can actually see a few names that are quite familiar. You may have participated in some high school programs or university activities previously, but we have partnered with Lockheed Martin and the university for the Altitude Accord. Basically, that's a strategic partnership launched by Lockheed Martin Australia in December 2018. In partnership with RDA Hunter and with the university. So it's a commitment by them as a large international defence industry prime to promote regional opportunities and jobs and education pathways for people in regional Australia and specifically for us here in the Hunter region, which is terrific. So some activities that we've done to support the development and tailor some of the curriculum for the university for the high value future skills of the next generation workforce. And Lockheed Martin is definitely looking at employing people in the next few years, as you'll hear. So we've done, during the past 3 years, we've done some really cool things, including engineering competitions for the Eng 1500 group 2019. The winners of that competition came with us on a scholarship tour of some defence industry sites, Lockheed Martin sites of the Eastern Seaboard. So we went down to Melbourne, up to Canberra, looked at some of the LMA offices and workshops, as well as some of their supply chain partners, which was really terrific. We've done, when COVID came to town last year, we changed a little bit and did some guest lectures. So zoomed across to some of I think Adam's team down in South Australia, and spoke to some engineers and tried to contextualise some of the learnings that you're doing at the University of Newcastle. And to continue on, yeah, Matthew came to us a couple of months back and said this opportunity was available, and it's a good chance to give Sean, Adam and Liam a chance to talk about their career pathways and also education pathways. So without further ado, I'd like to pass on to Adam Nemiznik for a bit of Lockheed Martin Australia context before we deep dive into a little bit of some support individual career pathways and job occupations. So over to you, Adam.
Yeah, thanks, Rick. So yeah, for anyone who's not aware, Lockheed Martin Australia, it's an Australian company. We've got something a bit over 1,000 employees. It's growing day by day. And we've got more than 12 facilities around Australia, the main ones being in Adelaide, Melbourne, Canberra, Williamtown. But there's also presence in Perth, Darwin, Townsville as well, and a few other regional sites. So you might have noticed a link in the chat window earlier. I'm just going to pop over to that and give you a bit of a walkthrough of some of the stuff that's going on within Lockheed Martin Australia. Hopefully you can see that. So firstly, there's the aeronautics division, which is hopefully something you might be familiar with. The F-35 Joint Strike Fighter is hopefully something you've heard of. But there's also the Hercules, Seahawks supported down in Nowra. The P3 Orion is actually sort of on the way out, so that's on a path to withdrawal. But you know, one of the core businesses is support of various aircraft that are in play within the Australian Defence Force. There's also the Missiles and Fire Control Division to do with some weapon systems missiles here. I don't know a lot of details about those, but they're in service. What I'm more familiar with is the mission systems side of things. So we've got the Aegis combat system in play on the air warfare destroyers. We're also managing the combat system integration on the Future Submarine program. And more recently, we're working into the Air 6500 program. Defense program is basically, they tend to start with air, land, sea, or JP for joint, and then you get sort of five magic numbers after it to define the program. So I don't know if anyone really knows how they come up with the numbers, but that's what defense programs look like. So 6500 is all about the future system for joint coordinated battle management of all the domains, so land, sea, air, space, and cyber, all in one. I forgot to mention on the aeronautics space, we also manage the pilot training systems based on the Pilatus aircraft, which is what RAF uses to start off their pilot training. Also, down the bottom here, we've got space systems as well. We've also got some programs in Australia, some sort of satellite uplink facilities, things like that. And then we've got a few R&D facilities as well. So the Endeavour Centre in Canberra and Stellar Lab in Melbourne have been set up as research and development labs where we can do targeted innovation and bring in Commonwealth stakeholders to participate in R&D exercises and things like that. And generally, you know, traditionally that's where R&D activities with universities have taken place too. And then finally on here, there's also some more civil applications, train management system with Australian Rail Track Corporation, and the program to commercialise flow battery technology, which is an interesting one there that I don't know much about, but might try and find out about. Yeah, I think that's about it, really. That's a summary of what's going on with LMA in general. We pass back to you, Rick.
Yeah, excellent. Thanks, Adam. So during our partnership, we've had sort of quite a lot to do with Lockheed Martin Australia, and they have a facility based out at Williamtown, near the McCure Hotel in the Williamtown Aerospace Centre, and have plenty of integration with RAF Base Williamtown. So that's how we've had the link in to do some really cool industry site tours pre-COVID. COVID times. So a lot of activity with 3 Squadron around the F-35 program that Adam mentioned. And I'm glad you mentioned the Endeavour Centre and Stellar Lab, because they were on the itinerary of the scholarship tour, and it was a really great opportunity for University of Newcastle students to go down and have a chat to engineers, technicians, and people that work for Lockheed Martin Australia. So I forgot to mention at the start, I do encourage you to put any questions in the chat, and we'll have Matthew Hackett will be sort of tabulating some of them, and following Sean, Adam, and Liam's presentations, there'll be an opportunity for Q&A. So to jump in to some of the individual career pathways and education pathways, in no particular order, but first up we've got Sean Owen, who is a systems engineer. He's going to talk you through where he's at currently and how he got to that position. So welcome, Sean Owen.
Thanks very much, Rick. And thanks, Matthew, and everybody for joining in. So I guess I'll start at the beginning of my journey. So back in 1990, a long time ago, I joined the Royal Australian Air Force straight out of high school as a technologist apprentice. And so over 3 years, I studied at the RAF School of Radio at RAF Williams in Laverton, just south of Melbourne. Great place to leave. Also attended Footscray TAFE, and we, as well as studying at the School of Radio, we also did an Associate Diploma of Engineering and Electronics. Graduated from there in 1992 as an avionics technician. So in 1993, I was posted to RAF Williamtown, worked on F-18 Hornet avionics systems, mainly using automated test equipment. In 1995, I achieved a placement on a then new scholarship program within the Air Force called the Airman Access to Academy Scheme. And I got a placement on that, and I was appointed as an officer and did officer training. In 1996, I commenced a Bachelor of Electrical Engineering at the Australian Defence Force Academy, and studied there as an undergraduate officer as opposed to a cadet. In 1999, I graduated with a Bachelor of Engineering. In 2000, I was posted back to RAF Williamtown to work at the F-18 Hornet weapon system support facility. After 1 year there, I was able to resign from the RAF, which was my want at the time, and became an engineering contractor with BAE Systems Australia. And that allowed me to continue to perform the same job I was doing, but as a civvy. At weapon system support facility housed the Integrated Avionics System Support Facility, or IASIF, which is basically most of the Hornet avionics systems, both real and simulated, connected together, basically networked together as they would be in the real aircraft. And it also included a set of cockpit controls and displays and indicators. So it was a highly advanced sim pit, basically. So while there, the work we did there was to make modifications to the embedded software for the F-18 Hornet weapon system, comprising the armament computer and the 2 mission computers. And we utilized the IASIF to basically fly the changes. So we'd make the changes and we'd actually fly them using simulation software and things like that. So while there, I led software development teams for doing that kind of work. I attained engineering authority to perform design review and approvals of engineering changes. And a lot of the work I did was mainly assembly language. One of the computers has an Intel 8086 processor at its heart. And as we know, real programmers program down to the bare metal. I also worked on updating some of the avionics simulations that we had there in C++. Worked on a project to create a desktop application in C# for pilots in doing their carriage release and jettison calculations for their missions. They used to do it manually using complex tables in documents, and it used to take them about 10 hours. And we created an application for them to get that down to about 10 minutes. So they were very, very happy with that. I've participated in software integration testing for a major UAV project, developed work instructions for software engineering activities, developed and delivered various training courses for updating the embedded software in those systems, heavily involved in configuration management and change management, and also worked in systems engineering whilst I was there, and worked in hardware engineering for a short period in integrating new systems into the IASF, including the F-18 Hornets electronic warfare suite upgrade. Then in 2016, I joined Lockheed Martin Australia as a systems engineer. My first role there was as technical and verification lead on a project to upgrade the RAAF's deployable long-range surveillance radars. In that role, I led an engineering team through phases like detailed design, critical design review, first article verification, as well as second and third article verification activities. And in that role, I provided leadership and tasking to the engineering team, and it was a highly successful project. From that, I wanted to get involved with the new shiny new toys, and took up a role as integration and test engineer for F-35 training system support. So in that role, I helped establish the Australian F-35 Training System Support Centre that was put in place for Australian specific changes to maintainer and pilot syllabi and courseware. I was heavily involved in developing the top-level change process that had been modified from the US process. But my primary role was to establish the integration and test portion of the design change process for making the Australian specific changes to syllabi and courseware. And of course, once we got that up and running, I was involved in the integration and test of various changes to syllabi and courseware, including the initial Australian specific F-35 pilot course syllabus. To do this work involved being read into a subset of the F-35 special access programs for highly classified capabilities of the aircraft. In that time, my work has involved stepping through a large portion of the F-35 pilot academics training on the various aircraft systems, which was extremely interesting. Unfortunately, with that role, there wasn't really much more progression from an engineering point of view. There was not really a progression in my engineering career happening there, so I changed roles again. So my current role is as what we call site systems engineer, and the main thrust of that role is to support and lead systems engineering activities across multiple projects, mainly in the Williamtown area, but it'll be involving projects in other parts of Australia. I've only been in that role for 3 or 4 months, but it'll involve conducting trade studies, participating in leading integrated product teams, managing system interfaces in larger system projects, developing model-based views of system architectures, and executing engineering authority to conduct reviews and approvals of key system design artifacts, supporting configuration management of systems, and to once again mentor and provide leadership to junior engineers. So that's me in a nutshell.
Yeah, terrific, Sean. Thanks very much for that. And to everyone on the line, if you could hold your questions again till the end, or pop them in the chat section. Thanks a lot, Sean. A really interesting career pathway, and we look forward to coming back to you with a few questions. If I could now pass back over to Adam, who is an engineering lead based out of Williamtown, but having previously heard from Adam, he works across multiple sites in Australia. So welcome back, Adam.
All right, thanks, Rick. So I've gone through a purely civilian path. I've never joined the Defence Force in any way, but I have somehow ended up in defence industry my entire career. So I studied a double degree at University of Technology, Sydney, did a Bachelor of Science in Applied Physics and a Bachelor of Engineering Electrical. And so that was 5.5 years, and 12 months of that was 2 6-month placements in industry. The first 6 months was done at Defence Science Technology, where I did some electronics work related to maritime mine countermeasures. And then my second placement was some time spent with what was called Thompson Marconi sonar at the time. I did some fun assembler work there related to degaussing systems, which minimize the magnetic signature of mine hunter vessels. Then once I finished uni, got a job pretty much straight away with Thales Australia, which is a French company that ended up buying out Australian Defence Industries, ADI. And I was within the underwater systems division, which basically manufactures several sonar systems on various ships in the Royal Australian Navy. So I spent a good 8 years or so as an electronics engineer, doing everything from circuit board design and manufacture and assembly through to integration and test and sea trials as well. And embedded software and high level software too. So I found that the border between hardware and software was already starting to blend quite a bit back then. Then after about 8 years as an electronics engineer, I changed roles to be more of a principal engineer position. So having sort of authority for the design of systems and the sell-off to the customer. So that was more focused on maritime mine warfare systems in particular. And that role sort of broadened the horizons a bit from, not just purely doing technical things, but, the industrialization aspects, commercial, having to identify suppliers in industry who can provide certain products and capabilities and sign them on and get them to deliver, and as well as interacting with the Navy on the customer side in identifying what their requirements are and doing the test and sell off of the stuff that gets delivered. So that involved a lot of international travel as part of that, because we had supply coming in from the UK, United States, various locations, trips to France as well. But as exciting as all that was, after about 9 years of that, I sort of felt like I had seen everything that was to be seen in the maritime defence space. And when I heard about Air 6500 and what it was trying to achieve, it sounded like a really interesting program to get in on. So about 10 months ago, I moved up to Newcastle and got a job with Lockheed Martin Australia, and haven't looked back since. A few years ago as well, while I was in that principal engineer role as well, that was the time when I went for my chartered status with Engineers Australia as well, because by that point I'd basically done all of the different competencies that they're looking for. It wasn't too hard to tick those off. And then at the moment at Lockheed, I am an engineering lead. I'm basically coordinating a few teams and a few sites of software engineers, R&D scientists, as well as other specialty engineering streams. And that's actually being done in quite a distributed fashion. So I'm based up here, normally out of the Williamtown office, but at home lately. But yeah, we're working closely with the core team at the Adelaide site, which is where a lot of our software engineers are. But we've also got quite a few people in Melbourne as well, and Canberra and Queensland. So yeah, that's me in a nutshell. Thanks, Rick.
Thanks very much, Adam. And our final panelist is a graduate hardware engineer. I believe went to the University of Newcastle. I hope I've got that right. But welcome, Liam McCowan.
Hi, everyone. Yeah, you are right. I went to the University of Newcastle and actually graduated at the end of 2018. So I did a double mechanical engineering and business degree through the University of Newcastle, and essentially applied for the LMA graduate program after finishing. So I was successful in that and started LMA in May 2019 and continued to work since then. So I was put on at Williamtown as part of the TADRS program, which is the RAF's long-range ground-based radar system. So that's been really interesting because we've been going through the process of a major upgrade to one of the components. So I came in just at the start of that, and we got to see from the kind of systems definition level, the requirement stage, all the way through detailed design into testing, and then handing over the first article to the customers now occurred. So we got to see the entire engineering process, and that's been really great for me as part of my development as an engineer. So it was really good timing and really lucky, and it's been a really good team in that. So I'm a hardware engineer. So some of my duties include like designing hardware parts, writing reports based around hardware definitions, but the lines tend to blur a little bit. So there's a lot of kind of architecture definitions and that sort of thing involved, and concepts for other systems that kind of move a little bit away from the hardware space. But that's primarily where I'm grounded. So for example, as part of this major upgrade to the radar system, got to do a lot of CAD work, essentially designing components, designing bracketry, and kind of the overall layout of where the ICT and computing hardware would be situated within the cabin. And because it's mobile, you have to consider things like shock and vibration. So there's quite a interesting approach and sorts of challenges that you maybe wouldn't see elsewhere, because it's not often you buy sort of data center level switches and then you have to make sure it can bounce down a dirt track in the bush. So you get some interesting challenges working on those sorts of things. So the graduate program is a structured graduate program, lasts about 2 years. I finished in early June or late June this year, so I'm now a full hardware engineer, I suppose. And yeah, that's been fantastic. I got to go to Adelaide as part of that, as part of a kind of graduate development event. There's been a couple of training courses for things like technical writing as I go. And yeah, over time, just a lot of support, mentors, people in my team, that sort of thing. So I'm very grateful that I was part of that. And I think it's the best place to start in this sort of industry. So now working as a hardware engineer on the TADRS program, as I mentioned, and some other things here and there, but that's primarily where I am at the moment.
Yeah, cool. Thanks, Liam. I can't believe it, gents. We've gotten through about half an hour of the presentation with, I'm only counting 4 acronyms, but and gone in to explain what those acronyms are. So across the 3 of you, sort of working across multiple programs. So the TADRS radar system, S6500 integrated battle management system, and the F-35, of which we in the Hunter know quite a lot about. So yes, some three really great career stories, working locally for basically an international defence industry prime, and making the time available to talk it through. There's a whole stack of questions coming through, which are really great, and I'll get to those in a moment with Matthew. But just to continue on the conversation, all 3 of you, I think, spoke a little bit about the travel opportunities, and maybe Sean, because you worked with the company pre-COVID, but can you talk about some of the opportunities you've had to travel with Lockheed Martin and other defence and defence industry partners?
Sure. Actually, when I first joined Lockheed Martin Australia in 2016, I was only there a couple of months, and I got a tap on the shoulder from my engineering project manager, and he asked me if my passport was in order. And in the middle of that year, I got to go to the US for a couple of weeks for a technical interchange related to the project that we were working on. So that was pretty cool. Although flying over the Pacific is fairly arduous. It's a good 30-hour trip going all the way from from Williamtown, making your way across the pond, all the way to Syracuse in New York State. But it was a fairly awesome experience. Yeah.
And Adam, you mentioned looking after mentoring some of the new graduates that come into the team and looking after teams across multiple sites. If you were to give some advice to a first-year engineering student, what would that be?
In terms of remote working? Or
yeah, I guess if you want to put it in today's current context.
just what does working look like these days? Yeah, so I think that the days of expecting the entire team to be co-located are dwindling rapidly. I think part of the recruitment drive for Air 6500 has cast the net a bit wider than purely Adelaide on the realization that we just wouldn't be able to support a program of that size and complexity if we did things that way. So a distributed team is definitely the norm now, and I think we're all the etiquette of working remotely, I think, is quite mature now. So if you were to come on board into my program, for example, you can expect to be interacting with people in Melbourne, Adelaide, Canberra, and Queensland on a regular basis. But we found tempos and ways of maintaining communications on a regular basis that doesn't leave you feeling isolated. So it's been good. It's been really fulfilling, and it's something I'm glad has worked out really well, because it's given me opportunities to get out of Sydney, basically.
Thanks, Adam. And Liam, really cool story coming through the University of Newcastle. We're obviously chatting to students from the local uni today. Have you got sort of an example of something that was really challenging in your engineering experience working on the TATRS program, and how did you sort of work to overcome that?
I think a good example is not really a specific event or project or something, but I think it's generally this level of culture shock when you come into a new industry, particularly defense. I remember probably one of my first meetings, I sat in a team meeting, and you joked about the acronyms earlier, but they were speaking English apparently, and I had no idea what was going on. It was just chaos, So I think you come in as an engineering student, and you finish and you feel quite confident, at least to some extent, in your abilities, and you go in there and you go, I can barely communicate. So I think there's definitely this struggle in going into, I can't speak for other industries, but for defense in particular, being completely unfamiliar with it and actually getting used to the terminology and how everything works. I think overcoming that sort of challenge, it's one is time and just immersing yourself in it. It's like speaking a different language. But the other one is really leaning on your team. I feel there's an absolute wealth of experience in the team in LMA, and particularly I can speak for the team in Williamtown, and they're always willing to help. So I think overcoming it and finding a solution to that really comes through being willing to ask the questions you think are stupid, or try to clarify and just try to sort of understand piece by piece and build into that role, because it would be very challenging to come in straight off the bat and actually understand everything that's being said. And to be honest, sometimes even now I hear some new program and there'll be an acronym or some sort of bit of terminology and I have no idea what that is. So yeah, I think really leaning on the team and trying to learn from them is how you overcome a lot of the things in this sort of industry.
Yeah, terrific. Yeah, I think I can see Peter Gibbons on the line as well. He sits on a coordination group at RAF Base Williamtown, and we go through 2 hours of meetings, and I'm constantly writing down acronyms, which takes another couple of hours to research and find out what they're actually talking about. So yeah, thanks for explaining what they all mean. And just a question, I suppose, an open question to the panel. Sean, you've worked for Defence previously. Adam, you've worked for a defence industry, and Liam, not with the ADF at all, I don't think. But can you sort of explain maybe first the benefits of working with defence, and then secondly, if you don't have defence experience, what the security vetting process looks like?
It's funny when people ask that question, what does it look like? Actually, it's a fairly vulgar description. I don't know if you've seen movies, but yeah. Defence offers, well, the thing that I've loved about defence is the toys, okay, the really cool platforms, weapon systems, depending on your philosophy, you know, in life. But there's a lot of really awesome systems that you work with. And lately the F-35 is an incredibly awesome system, regardless of what people say. Having been privy to a lot of the classified, or some of the classified capabilities, I can say that it is an absolutely extremely impressive feat of technology. In terms of the vetting process for obtaining the necessary security clearances, it's been very uncomfortable for a couple of hours of your life, basically, apart from having to divulge every single detail of what you've been doing for the last 5 or 10 years, and your entire financial history, and all of your finances, your current finances, your everything to do with everything you've obtained credit for, car loans, what you paid for a car, what it's worth now. It's just crazy. They go into a lot of detail, but it's discomfort and frustration for a very short amount of time. But the benefits are fairly awesome when you do end up getting a clearance, because then this new world sort of can open up to you in terms of things that you're now involved with. Hope that sort of answers that.
And
yeah, absolutely. Thanks. I guess just wanted to cover across that, as you know, we're looking at first, second, third, and possibly fourth year engineering students, and just what is the criteria to get into defence and defence industry.
I think the longer you've been around, the harder it is, because you've got more that you've got to divulge. If you're just graduating and you haven't done much, you haven't been many places, it makes it much easier.
Yeah, get in early, everyone. Adam, sorry, did I cut you off there?
I was just going to add that defence projects generally run for a long time, and even when the development, the delivery and acquisition process is finished, the support of those systems can go on. So in terms of job stability and that sort of thing, it's a lot more stable than a lot of other industries.
Yeah, sure. Last one from me before I pass on to Matthew Hackett to start going through some of the audience questions. Sean, how much of a step change was the transition from Hornet to F-35? Question without notice. Sorry about that.
In terms of the technology, or what sort of context? What do you mean?
Yeah, in terms of technology, how much?
Okay. Well, I mean, the F-18 Hornet was developed, I think started development in the 60s or 70s, and then we got it in the 80s. And so by the time one of the things in defence is usually by the time you sort of get onto working on a defence system, it's actually already 15 to 20 years out of date, because of the lead times in acquisition and support and things like that. And then when Australia gets sort of that sort of technology, but I think that's sort of shortening as we go along, and with Air 6500 when we're actually creating the technology. So I think that's getting sort of shorter and shorter. But yeah, going from the F-18 Hornet to the F-35 is just a major jump in technology and how things work. Yeah, I think that's about all I can say. The actual engineers who worked on the part of the actual engineering for the F-35, they're sort of back in Texas in the US. They're in Fort Worth and other various places around the US. So my experience with F-35 is mainly in the training systems. In terms of training systems, they're just absolutely world class and really bringing technology to the fore in terms of training delivery. It's actually really amazing to see, and it's amazing it's amazing the integrated systems. The fact that and actually one of a major key difference between the older 4 and 4.5 generation aircraft and the 5th generation aircraft is actually the integration of the air systems and the training systems. So Australia purchased an air system, which involves the air vehicles, the actual aircraft and the support systems for that. They also purchased the F-35 training system, which all the training systems, and they're actually integrated. And this is the sort of the paradigm that Lockheed Martin in the US is putting forth, is this providing training systems and keeping them in step with the aircraft, even as the aircraft evolves, as they do technology replacements on the aircraft. They have systems for keeping the training systems in step with those technologies and in step with the aircraft, and it's quite amazing to see.
Yeah, terrific. Thanks, Sean. Plenty of questions. Matthew, I will hand over to you.
Yep. Thanks. There's been a lot. So if you just asked one, I'll get to it towards the end. I'm going from top to bottom. So Rick, question for you. So what opportunities for engineering students are there going to be to visit the RAF base and Lockheed Martin engineering areas? Because you said you've done that in the past through the Altitude Accord. Is there going to be opportunities in the coming years to do that?
Yeah, thanks, Matthew. Absolutely. So there's intent. The partnership between Lockheed Martin Australia, University of Newcastle, and us will continue. We've got intent from Lockheed Martin Australia and RAF Base Williamtown to provide site tours and industry visits when we're able to get out there. Yeah, the tour that we ran in 2019 was really successful, and we'd be looking to sort of emulate that when and if we can with these COVID restrictions. But yeah, definitely great opportunity to get out there and look at some of the platforms and talk face to face to some of the people that are working on those platforms.
Great. Question for you, Sean. Do you use things like model-based systems engineering? And is being a systems engineer kind of like project management, but with more technical awareness, making high level or architectural decisions?
In terms of model-based systems engineering, Lockheed Martin Australia has for quite a while now been pushing to make use of model-based systems engineering, and there's a lot of companies, a lot of engineering companies out there that have been doing this for a while now, and there's a lot of benefits in that. There's a lot of new software architectures or enterprise solutions that are being produced to facilitate model-based systems engineering. And the benefits are that if you have your system architecture all sort of modeled, then when you change something, so you say, well, we're going to change something in this rack, we're going to put this equipment in here, then theoretically that model-based systems engineering would then recalculate things like electrical loads, the air volume for cooling and things like that, and would actually then readjust everything in real time. So those calculations could be done, so you could see the impacts. The impacts of making a change in your system architecture could then flow down. So I guess in answering the question, yes, Lockheed Martin Australia is definitely embracing model-based systems engineering. I haven't been in a position to be involved with it previously, but they want me to get all trained up. So I'm in the process of being trained up in how LMA is using that now. And then the next question was about systems engineering.
Yeah,
Sorry?
if I was just going to reiterate the question. Is it more like a project management position versus technical?
I hope not. Nothing against project managers, but I don't want to be one. Systems engineering is something that it's preferable. Like, I guess as graduates, don't worry about going into systems engineering. Systems engineering is extremely important, and if you Google systems engineering, you'll see that it was born out of I think the 50s or the 60s from projects, major defense projects in other countries like the US, where things went really badly, things went wrong, and it was born out of the fact that there were subsystem teams that weren't communicating with each other, and things went wrong. Something along those lines. There's ballistic missile projects and things like that. Systems engineering is extremely important. As a systems engineer, you're over the system and the subsystems and how they interact and the interfaces between them, as well as I'm very much simplifying it. But as an engineer, specialize first. Do your mechanical engineering, your software engineering, information technology, computer engineering, and things like that. Work in those fields. Have an appreciation of systems engineering and an appreciation of why there are systems engineers coming to you, asking you about the interfaces coming out of your particular subsystem. But systems engineering is more for somebody who's been in the field for a fair while, because of the taking that systems view, and it's probably not as sexy as doing your CAD drawings or creating your software or doing calculations and things like that. However, it's extremely important in the overall system architecture. I hope that answered that.
Great. And just a comment from Peter Gibbons about the aerospace engineering systems degree. We do systems engineering in fourth year courses, so you get plenty of background.
Yeah, and in my electrical engineering degree at the Defence Academy, we did a unit of systems engineering, and I believe all engineering courses should have a component of systems engineering, because you should graduate with an appreciation of systems engineering in how you fit in to the whole system engineering paradigm, I guess. Yeah.
Question for Adam. What does it take to become a chartered professional engineer, and what benefits does it provide in the workforce?
Yeah, so I think similar to what Sean's just said about getting into systems engineering, I think it's not something you target initially. I think, focus on doing electrical or software or mechatronics, mechanical, whatever it is you're specializing in first. But the idea of the CPEng program is to, after a certain point of time, you'll find that you've accrued enough experience in different competency areas to be able to demonstrate that you can approach the different facets of what is involved in an engineering career. And what that really does is it formalizes your commitment to engineering as a profession, and the ethics that are involved with that, responsibility to the community and the users and the environment and all sorts of things. And it really just codifies all of that and formalizes an accreditation that says, yes, you have competencies in all of these areas. And what that ultimately means is that you can then hold a position of engineering authority where you are signing off on key design decisions in major systems that are being used by actual people in the real world. So if it all depends on what your aspirations are. If you want to work at a senior level and be a key decision maker, in that space, then I think it's basically given as a requirement.
Great. That's a question to anyone. What's the scope of software engineering in the Defence Force? So what sort of roles are there available for a software engineer?
The Defence Force itself doesn't really do engineering. They contract out, but I guess you're referring to defence projects. A lot of it, any software that Lockheed Martin would do would be developed probably in Adelaide, because a lot of the greenfield stuff is done in Adelaide or Melbourne or something like that. Adam, you probably talk a lot of that.
We're working on that.
Yeah, it's changing. Of course,
It's
with the
changing.
current environment, they're starting to sort of divest more out to remote sites, if you could call Newcastle remote. But yeah, I think it depends. It all depends on the risk. So in terms of the compromise between using commercial off-the-shelf software and developing it in-house, but then again, it also depends on the system. The submarine program that Adam mentioned, developing combat systems and things like that, that could most likely be done in-house because it's a safety critical and mission critical system. So things like that, you'd get software engineers in-house to sort of develop that. But if it's applications, it would be a compromise. It might be commercial off the shelf, or it might be developed in-house, but I don't know. I haven't seen a lot. I haven't seen a lot sort of developed in defence projects.
What are some of the benefits of working at Lockheed Martin over other companies, and how have you sort of dealt with the COVID situation? Have they been pretty flexible?
Extremely flexible.
Yeah,
This is the thing, rock solid.
I've found Lockheed's approach to work-life balance and flexibility to be exceptional. Having been in other defence companies as well, they have a genuine commitment to that. And for starters, most of us work on a 9-day fortnight. So we work an extra little bit each day, and then we get every second Friday off, which is a really good arrangement.
Great. Liam, a question for you. Sort of what was a day in the life that you would experience? Like, what was your average day in the grad program, and then now that you've finished that grad program?
An average day was pretty close to my day now, to be honest. The grad program is essentially puts you into the role that you'll be doing. So it's not one of those programs where once you finish, you'll have to apply for a job, or it's not one of those programs where you get rotated through a lot of different things. So my role actually didn't change all that much, but the level of responsibility and authority does increase with the promotion that you receive.
Can you detail sort of like what was the day? Would you do sort of maths-based calculations, or how would that, like, what would you do on your average day?
It would vary. So like I said before, there was quite a lot of design. So that was primarily using Creo. So hardware designs, 3D modeling, create a drawing, often speaking to a manufacturer, trying to get that drawing manufactured, maybe a bit of back and forth with procurement, that sort of thing. Bigger things would often require some sort of report or some sort of analysis to be produced and then approved as part of our team. Discussions with the customer in terms of feedback from reports, or trying to kind of distill what they want for certain things. Pretty much anything, really. The other thing that's very, very commonplace is peer reviews. So either being an author and having your document reviewed, or whatever it may be, could be a drawing, could be code. And then back actually being the reviewer. So there's quite a lot of that as well. Yeah, it's just standard engineering day, really. And yeah, not much changes when you finish the graduate program.
Great. Well, to everyone, Lockheed Martin looking for any specific type of engineering degrees, or is it more you go in as something like a hardware engineer, you do much more job-based learning?
Don't mind who goes. From my perspective, I'll just jump in quickly. Hardware engineering is super broad. So I'm closely aware, shall we say, of 4 graduates, including myself, who've gone through Williamtown recently, and I'm mechanical and business. Then we've got a mecha, we've got a mechanical, we've got an electrical. All of us are hardware engineers. So it's very broad in that sense. I think obviously if you did software comp sci, you'd go into the software side of things, but it's quite broad. So they're not looking for anybody in particular. Obviously aero would go into hardware as well, or any other of the kind of subspecialties.
Another question for you. Or everyone really. What does Lockheed Martin expect from a graduate? So soft skills, technical skills. What are the expectations from a graduate student?
Obviously you should have a high technical standard. I think that goes without saying. But the soft skills are crucial, and I think that's something I'd emphasize. A lot of the work we do involves a lot of communication, whether it's in your team, whether it's outwardly to the customer or to different teams, up to executive level or down. The soft skills are crucial, but yeah, don't neglect the technical skills as well. They want somebody well-rounded, basically.
To everyone, what stage of university degree would you recommend looking for an internship and that 12-week industrial work experience? And what opportunities does Lockheed Martin provide in that aspect?
Yeah, I can jump in on that one. So we've been working with the RAF base Williamtown around providing a program of works to provide work integrated learning across defence and defence industry partners. And we understand sort of the requirement for how long you need in that experience. This latest little breach of COVID has possibly put us back in terms of the face-to-face and the security requirements to get onto base and to get into some of the defence industry sites. But there is an ongoing conversation, and we completely understand the amount of students that are coming through the university that require that work integrated learning.
So would you recommend someone in their second year to be looking for that, or wait until a bit later in their degree when they have higher technical skills ability?
Yeah, so we've had conversations around that as well. And I mean, if you do have a connection into a company, feel free to make that happen yourself. But yeah, the conversation again with the Air Force and defence industry partners is to get as much experience between first and fourth year as possible.
Great. I don't know if this one's for you or maybe Adam, but so how would a PhD student or someone with previous industry experience, but not specifically engineering, fit into your recruitment process? So would they had to go through the grad program, or would they have to sort of bypass that step and go into just a regular engineering role?
Yeah, by all means, you don't have to come in as a grad to be able to get in. We take people in at any stage in their career, really. I think the key things we're looking for are really, possibly sort of attitudes and behaviors, and an ability to use the latest technologies. So I think it's, we can't really expect everyone to come with a full set of experiences that just happen to magically line up with everything we need. It's it's not going to be realistic. So I think what's more important is the ability to be able to plug into a team and come up to speed rapidly with all of the new sort of terminologies and domains that you're going to have to come up to speed with. So we've taken in people from all walks of commercial industry that haven't necessarily had defence experience, but they've got relevant skills in applying technologies in different industries. So for example, if you'd completed a PhD in another area, I think we're exploring ways of how we can make opportunities available at different levels. So I think the initial focus is on the graduate entry point, because that's a bit easier to manage. But I think PhD engagement and postgrad and beyond is something we need to figure out as well.
Right. To everyone. So, how would an international student go about applying for a defense industry based job in Australia with security clearances and things?
Generally, to get what they call NV1, which is secret level, you generally need to be Australian citizen.
So is that pretty much just become an Australian citizen first and then?
I think
apply?
so. There will obviously be various complications there because it gets complicated, but yeah, generally you need to be an
You
Australian.
need to be an Australian citizen. Yeah. Speaking of international, how much international collaboration does Lockheed Martin Australia do? I guess that sort of ties into, is there like international travel and things like that possible?
Say a lot.
Yeah, fair bit. Sorry, Adam, you go ahead, Adam. Yeah.
Oh, just every major defense company of the 1,000+ size has parent companies overseas, whether they're in Europe or the United States, and a part of doing business is technical interchange with the parent companies, having that back and forth. So, and on top of that, you've also just got the broader industry base worldwide. Only so much equipment comes out of Australia, not a huge amount really. So inevitably, there are lots of opportunities for international interaction and some long flights. But as Sean said, it's generally a good experience if you get the opportunity.
And one of the things to keep in mind is that generally the Australian companies are generally integrators. We're generally what we call prime integrators or integrators of systems supplied from the specialists generally in other countries. Although we in Australia we have various companies have produced some fairly Gucci stuff, but generally the companies that like Lockheed Martin Australia, BAE Systems Australia, Boeing Defence Australia, we generally integrate systems to produce new capability for the customer.
Great. How much maths do you use in a day-to-day basis? I was asked in the chat, someone's a software engineer, not very strong with maths. How much maths do you use? Not.
I'm saying none really.
Very little.
Yeah, if we have tools.
It's if you're doing the really low level engineering development, you're developing new technologies, or I don't know, Liam probably does some calculations for stresses or heat or conduction or things like that, but very little.
Be a data analytics nerd, get into AI, ML, all that sort of stuff. But again, I'd be surprised if you actually needed to do the maths. A high level understanding of it, I think, is more important than being able to mechanically do the calculations.
Yeah. So if you go, I'm sorry.
I was just gonna say, yeah, in my experience, that's pretty true. There's not a huge amount of maths. Whether that's a good thing or a bad thing is probably an individual point of view. I'll do some calculations in terms of hardware, and it's very important to understand the fundamentals. So, for example, if you do some FEA on a bracket, you can actually justify what you're saying and what you're actually presenting as an outcome. But no, day to day, not much maths at all.
Yeah, but if you were to go into the more the research and development route, would you use more in that circumstance? Potentially.
Depends what sort of research and development. Sorry, I'm being vague.
Adam, how much of a presence will Air 6500 have in Newcastle, if you can say, or is it going to be more Adelaide?
Well, we're aiming for significant. There's a desire to build up Newcastle as a regional hub to support it. The Williamtown RAF base is here. That's where our customer for that capability is going to be. So that's the plan.
And I assume there's going to be associated jobs with that.
Yeah, absolutely.
I think this is the last. Just let me look at the chat quickly. Sorry. Just a note from Peter saying, with model-based engineering, people involved in developing the models. may need to apply their maths more than people using the models. But last question, if you're allowed to say, with working with the F-35, I think this is more an interest question. Can you tell us about anything about the AME 3s and what's inside them?
What's an AME 3?
I don't know.
AME,
The person who asked that question, if you can
alternate mission
clarify.
equipment. I think that's getting too specific.
I would imagine that's probably a bit.
And I
too
have no
specific.
idea. I've never heard of an AME 3. I've heard of AME, alternate mission equipment, but not an AME-3. No idea.
Okay. Last question. Oh, sorry, Mohammed. I will answer that question. I must have absolutely skipped it. Are the salary ranges published for graduate engineers at Lockheed? If anyone's happy to say that, like competitive.
Generally, we don't. Obviously, we don't divulge that sort of information between us. I think ranges are generally given when you apply. I can honestly say myself that it's extremely competitive, and I have never complained about my salary, but I'm not sure from the point of view of a graduate.
And final question, if you could start your career, we'll go through each of you. If you could all start your careers again, what would you do differently this time if you're modern day?
For me, going through uni, the Defence Academy, I would find out how doctors and lawyers do it, because they've got it down pat in studying and how they do their learning and all their techniques. And I'm really annoyed that I didn't get shown that when I did my degree. And there's various things throughout my career that I do differently, but unfortunately, hindsight's 2020, and you've just got to live and learn, I think.
Yeah, I think I would learn now rather than 20 years ago, if that's right, when the internet was only just starting, because access to information now is just incredible. You can basically access tools within a short period of time to put together a speech recognition system and do tutorials and teach yourself how to do all of that. That access to that sort of tool set and information just wasn't around when I was in uni. So part of the difficulty that I had back then was when you're doing a project, just finding the information, getting access to all of those things was just difficult. So I think I probably didn't build as much as I probably would have liked. So I would say build more.
And Liam, I guess as a more recent graduate, do you have any specific advice for a third or fourth year student looking for a graduate role?
I think the key is, it sounds cliche, but be passionate. Have an interest in the industry, understand what's going on in the region as best you can, and yeah, be excited about it. The other thing is, I mentioned don't neglect soft skills. Very important. Joining clubs at uni help. One of the graduates I work with, or he's not a graduate anymore, just like me, was heavily involved in SAE at uni, and that served him really well. So if you're passionate about that sort of thing, get involved. Yeah, it all helps. Sean mentioned earlier that systems engineering, yep, not a specialization in it, but an understanding of it is very important. And the other thing that is potentially not covered as much, at least in the hardware side of things, is networking and ICT type stuff we deal with quite heavily. So those would be my recommendations. Obviously, study your core specialization and be really good at it, but kind of don't neglect the broader things, whether that be other facets of engineering or soft skills.
One last question that just came through before we wrap up. Will the software engineering roles use machine learning or have machine learning capabilities?
I'm going to say yeah. It's AI ML is going to be a basic enabling technology that will just be prevalent. If kind of already is, honestly. So
Okay. Oh, thank you very much, everyone. Thank you for your questions. Big thanks to Adam, Sean, and Liam from Lockheed Martin, and Rick from RDA Hunter. Yep, thank you very much. We'll post the recording of this session on our Facebook. If you want to go through and listen to any of the questions again, or listen to anything that Adam, Sean, Rick, or Liam spoke about. And also we'll post on our Facebook page about any more future industry or social events that we've got coming up. So if there's any other final comments from you guys, we'll wrap it up.
Yeah, Matthew, I'd just like to jump in and say thanks for the opportunity. I do also notice there's quite a few girls on the line, and there's lots of opportunities with Lockheed Martin Defence and defence industry for females in any of those roles. So please continue on your engineering pathway. And as I mentioned at the start, we definitely like to continue the momentum of this partnership, and look forward to hosting a lunch or possibly a beer in the afternoon, and everybody can have a face-to-face conversation. So thanks again, Matthew, and thanks, Sean, Adam, and Liam.
Thanks, guys. Thank you.
Oh,
Thank you.
Yeah, I'll just unmute Peter quickly. I think he has Aero Professor. I think he might have
Yeah,
something
can
to
you
add.
hear me?
Yeah.
Yeah, I just thought I take the opportunity to thank you for organising this, Rick for coordinating, and particularly on behalf of the students and the university. Really, I'd like to thank the participants, Sean, Adam, and Liam, for their words of wisdom and their words of experience, which will benefit our students no end. And just one more thing. Earlier, there was a question about opportunities to visit defence bases. We do try and coordinate a few of those things with Rick and Defence Force recruiting several times a year. There is one planned for the end of September-ish, but given our current lockdown situation, that might be a little bit flexible. We'll keep advice as to the status of that as things develop with the COVID situation, and I'll keep you advised. But otherwise, thanks for Lockheed Martin on behalf of the university for all your participation, and we're really keen to keep these links going, and hopefully maybe some time down the track to get some of your professional input to some of our coursework if that opportunity arises. Thank you.
Well, thanks very much, Peter. Well, anything, sir? Thank you very much for coming, everyone.
all right, thank you, everyone.